reverse neutral and ground is a serious electrical hazard and should be corrected as soon as possible by a qualified electrician. In a properly wired system, the neutral conductor carries the return current from the load back to the source, while the ground conductor provides a low resistance path to ground for fault currents. Reversing the neutral and ground conductors can create a situation where fault currents flow through the neutral conductor, which can overheat and cause a fire. Additionally, it can create a voltage potential between the neutral and ground conductors, which can shock anyone who comes into contact with both conductors. The neutral conductor is intended to carry current under normal operating conditions, providing a return path for the electricity powering devices and appliances. It is typically identified by a white or grey insulation. The ground conductor, on the other hand, is designed to provide a safe path for fault currents, such as when a live wire comes into contact with a metal enclosure. It's usually bare or has green insulation. When these conductors are reversed, several dangerous scenarios can arise. Firstly, appliances and equipment that are normally grounded can become energized. This means that metal parts that are not supposed to carry voltage could become live, posing a shock hazard to anyone who touches them. For example, if the neutral and ground are reversed and a fault occurs in an appliance, the appliance's metal casing could become energized, and touching it could result in an electric shock. Secondly, the risk of electrical fires increases significantly. The neutral conductor is not designed to handle the same level of fault current as the ground conductor. If a fault current flows through the reverse neutral conductor, it can overheat and potentially ignite nearby combustible materials. This is especially dangerous because the overcurrent protection devices, such as circuit breakers or fuses, may not trip as quickly as they would if the ground conductor were properly connected, allowing the overheating to persist and escalate into a fire. Thirdly, sensitive electronic equipment can be damaged. The improper grounding can lead to voltage fluctuations and noise in the electrical system, which can interfere with the operation of electronic devices and even cause them to fail prematurely. Computers, televisions, and other sensitive electronics are particularly vulnerable to damage from reverse neutral and ground connections. Identifying a reverse neutral and ground can be challenging, as it may not always be immediately obvious. However, there are a few telltale signs to look for. One common indication is a tingling sensation when touching metal appliances or fixtures. This suggests that there is a voltage potential between the metal and ground, which is a clear sign of a wiring problem. Another sign is erratic behavior from electronic devices, such as flickering lights or unexplained malfunctions. These issues can be caused by the voltage fluctuations and noise associated with reverse neutral and ground connections. If you suspect that you have a reverse neutral and ground, it is crucial to take immediate action. Firstly, do not attempt to correct the problem yourself unless you are a qualified electrician. Electrical work can be dangerous, and improper repairs can create even greater hazards. Secondly, contact a licensed and experienced electrician to inspect your electrical system and make the necessary corrections. They will have the tools and expertise to identify and resolve the issue safely and effectively. Thirdly, while waiting for the electrician, avoid touching any metal appliances or fixtures that you suspect may be energized. This will minimize the risk of electric shock. Correcting a reverse neutral and ground involves several steps. The electrician will first identify the source of the problem, which may be at the service panel, an outlet, or a junction box. They will then disconnect the power to the affected circuit and carefully rewire the connections, ensuring that the neutral and ground conductors are properly connected to their respective terminals. Once the repairs are complete, the electrician will test the circuit to verify that the problem has been resolved and that the electrical system is functioning safely. In addition to correcting the reverse neutral and ground, the electrician may also recommend other electrical safety measures, such as installing ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electric shock, such as bathrooms and kitchens. GFCIs are designed to detect even small imbalances in current flow and quickly shut off the power, preventing potentially fatal electric shocks. Regular electrical inspections are also important for maintaining the safety of your electrical system. A qualified electrician can identify potential problems before they become serious hazards, and they can ensure that your electrical system is up to code and functioning properly. During an electrical inspection, the electrician will typically check the service panel, wiring, outlets, and other electrical components for any signs of damage or wear. They will also test the grounding system to ensure that it is functioning effectively. Electrical safety should always be a top priority. By understanding the dangers of reverse neutral and ground connections and taking proactive steps to prevent and correct them, you can help protect yourself and your family from electrical hazards. Remember, if you are ever unsure about the safety of your electrical system, it is always best to consult with a qualified electrician. They have the knowledge and experience to ensure that your electrical system is safe and reliable. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including the proper wiring of neutral and ground conductors. Adherence to the NEC is essential for ensuring the safety of electrical systems. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. State and local jurisdictions often adopt the NEC as their standard for electrical installations. The electrical inspectors enforce the NEC to ensure that electrical work is performed safely and in compliance with regulations. Proper grounding is a critical aspect of electrical safety. A properly grounded electrical system provides a low resistance path for fault currents, which helps to protect against electric shock and fire hazards. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the service panel and the grounding conductors throughout the electrical system. The grounding electrode provides a direct connection to the earth, which helps to dissipate fault currents safely. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electric shock. GFCIs are designed to detect even small imbalances in current flow and quickly shut off the power, preventing potentially fatal electric shocks. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or ASIs, are designed to protect against electrical fires caused by arcing faults. ASIs detect the unique characteristics of arcing faults and quickly shut off the power, preventing the arc from igniting nearby combustible materials. ASIs are typically required in bedroom circuits and other areas where there is a high risk of electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against overloads and short circuits. These devices interrupt the flow of electricity when the current exceeds a safe level, preventing damage to electrical equipment and reducing the risk of fire. Circuit breakers can be reset after they trip, while fuses must be replaced. Regular maintenance of electrical systems is essential for ensuring their safety and reliability. This includes checking for loose connections, damaged wiring, and other potential problems. It is also important to keep electrical panels and equipment clean and free of debris. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, it is important to investigate the issue promptly and consult with a qualified electrician. Ignoring electrical problems can lead to serious hazards, including electric shock and fire. Electrical safety is a shared responsibility. By understanding the risks and taking proactive steps to prevent electrical hazards, everyone can contribute to creating a safer environment. Remember, when in doubt, always consult with a qualified electrician. They have the knowledge and experience to ensure that your electrical system is safe and reliable. Firstly, the reverse neutral and ground can energize metal parts. Secondly, this issue increases fire risk. Thirdly, it can damage sensitive equipment. It is important to note that this is a serious safety hazard and should not be ignored. If not comfortable working on electrical systems, it is best to call a qualified electrician to make the necessary repairs.